This is the second in a series of models for Systems Academy. This is linear inflow and exponential decay, the basic equation. This video is going to be about the rain barrel model. So this is going to be a rain barrel. So this is the level in the rain barrel, the level of water. And you remember from our previous first video about this that the level was 50 and it was constant. So that's what this little graph shows you. The inflow is a constant 10. So in this case we're going to call this a faucet. So the faucet is controlled to let water come into the rain barrel. So we might have a pipe coming from a collection device and we want to control the flow going in. In this case we've already put a number in the equation for, and we can look at push the button for equation and look here, and we see this value of 10 for the inflow. That was from our previous video. Okay, so we have a faucet, we have a rain barrel, and now instead of decaying, we're going to change the name of this variable to draining. So the faucet here controls the flow going into the rain barrel, and then there's a drain that controls the flow going out. Now that drain could have a valve on it that we use to control the flow going out. So we'll just call that a valve that's draining out. And then we have a rate of the drain is going to be 5 in this case. So we still have the same equation for draining. It's the level divided by the rate of drain. So level starts out at 50 and the rate of the drain is 5. So every time period it's going to go out by 10. And we check the model settings. We see that the model settings, we're going to run it from 0 to 100. Let's make it 0 to 50, 0.0625, and RK4 is the integration type. Alright, say OK. We're going to run the simulation. It's going to ask me if I want to change the data set. I'm going to say yes. I just leave the name. This name up here says current. For these videos I'm just using the same name all the time. That's why it keeps asking me. Over here we're going to check the graph. Let's select the level first so that we get the variable that we want. And then we're going to check on the graph. And just like in the first video, the inflow is 10 and the outflow is 10, and we start with 50 in the level on the rain barrel, and it stays 50 for the whole time period. So this is in equilibrium. Again, we've changed the names, but the basic equation remains the same. Why is that? Well, in physics, the column of water in the rain barrel has pressure on the hole in the bottom of the rain barrel. And it's proportional, the height of the water in the rain barrel is proportional to the rate at which the water drains out of the rain barrel. So the rate of drain, it represents the size of that hole in the bottom of the rain barrel. And so this equation, if you compared it to an actual rain barrel, you could change the size of the hole by adjusting the valve, and you could figure out what the rate was. And if you compared this to an actual rain barrel, you would be able to match this model to the actual flow in and out of a rain barrel or a bathtub or anything where a container that had water coming in at the top, and you had a hole in the container at the bottom where gravity was causing the water to drain out, and the height of the water was proportional to the rate of the drain. So this is your basic equation for linear inflow and exponential decay as applied to a rain barrel or a bathtub, where the physical material going through the model in this case would be water. So that's the basic equation that we're talking about here.